So when you're looking for horizontal tangent, show me with your arms, what does horizontal tangent look like? Perfect. What's the slope of that? What's that? 0, right? So this has to be equal to 0. So which do you set equal to 0, dy d theta or dx d theta, do you think? Dy d theta. So all you do is set dy d theta equal to 0. So in this case, it's going to be the derivative of r sine theta is going to be r cosine theta d theta equals 0. And by the way, what angle will the cosine be equal to 0? Tell me a couple. Pi over 2 is 1. What else? 3 pi over 2, 5 pi over 2, 7 pi over 2, right? Just these forever and ever and ever. So theta is going to be dot, 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 pi over 2, 3 pi over 2, and keeps going. 5 pi over 2, 7 pi over 2. Let's try, you try it with the vertical tangents. This time we have dy d theta over dx d theta. And this time we want the slope to be what? Show me with your arms. So what slope is that? Undefined. What's 0 this time? The numerator or the denominator? The denominator is 0. So this time we're going to set dx d theta equal to 0. So we'll take the derivative of dx r cosine. So it's going to be r negative sine equal to 0. And what places on the unit circle will that be true? Zero, pi, 2 pi, 3 pi, 4 pi, an infinite number of those. So we'll just call this theta equal to dot, 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 0 pi, 2 pi. Does that help a little bit? That's the easy part, but it's kind of nice to know. Now watch this. Find the slope of the tangent line when theta equals pi over 3 and r equals this. It's a shape. If we take the time, you could actually draw it. It's pretty cool. R equal 1 plus sine theta. The equation for x is r cosine theta. So what we're going to do is we want to find dy d theta over dx d theta, right? Now, before we do this, we have to substitute r in here. And r was 1 plus sine theta and times cosine theta. So now when I take the derivative, dx d theta, do you see the challenge? Do you see what the problem is going to be? Right? Little hi-ho. So we're going to go hi, 1 plus sine theta. D ho is negative sine theta. Plus ho, which is cosine theta. Derivative of this is cosine theta. And let's see. Negative sine theta minus sine squared plus cosine squared theta. And now we put the pi over 3 in. And what's the sine of pi over 3? Sine of pi over 3. Is it 1/2 or square root of 3 over 2? Which one? For sine. Is it x or y for sine? Come on. Scaring me. Yeah. It's sine is the y. So this is going to be negative square root of 3 over 2. And then we're going to square it, gives you 3/4. And then we're going to square the x and you get plus 1/4. So, yeah, that is dx d theta. Now I want you to find dy d theta, and I'm going to have you do it. No, it's not going to let me, is it? Now we're going to find dy d theta, and it starts with y equal to r sine theta, and we replace that r with 1 plus sine theta. And you have to, unfortunately, do the hi-ho. Please do that. Give that a go right now. Give me the dy d theta. Take a little time. You got a Heidi-ho in there. So I get hi, which is 1 plus sine theta. Derivative of sine is cosine, plus ho, which is sine, and derivative of 1 is 0, sine is cosine. So this one is going to be cosine theta plus sine theta cosine plus sine theta cosine. So I think it's going to be plus 2 sine theta cosine theta. So this one, when I put the pi over 3, the cosine is 1/2. Do these consistently. So it's going to be 1/2 plus 2 times sine, which is square root of 3 over 2, times 1/2. So no kidding, you put this in your calculator, and you'll get the slope. That's a lot of work for finding the slope, isn't it? And that would be one of the tougher things they'd ask you to do for polars.